So the last time I saw you, we did the combinations of functions, combinations, adding, subtracting, multiplying, and dividing. And today we're moving on to the little part we skipped, which is called composition of functions. That means we're composing one function with another function, which I'm going to show you a little diagram I have because I think it explains it really well. I keep this, it's up on the wall in my room. It's just a picture of this diagram that I made that I think is kind of awesome. So I'm going to blow it up a little bit. When we're composing functions, we have two functions. Say we have f of x equals Bugs Bunny, right? And we have g of x, which is another function, and it equals Stalin, right? Now, if I have f composed of g, that's what this is right here, this little circle is f of g of x. It means that I am going to plug whatever g is into whatever f is. So in this case, I am plugging Stalin into Bugs Bunny, right? And if you look at this one, I've got g of f of x, and I'm plugging Bugs Bunny into Stalin, right? And that's basically all we're really going to be doing with this math, right? Is I'm going to get two functions. It'll be f of x and g of x, or g of x and h of x, and we can call it anything we want. But wherever I have an x in whichever one I'm plugging it into, I'm going to plug in whatever the like the g of x is. And so I'm gonna show it to you. I just wanted you to kind of see it as Bugs Bunny and Stalin first, because who doesn't want to watch Bugs Bunny get plugged into Stalin and vice versa. So we're gonna head back here and we're gonna talk about composing functions. So you're going to see it written in certain ways. You might see it written as it was over there where we'd have f o g, which looks like fog, of x, right? But it really just means that we're taking f of x, and inside what we're inputting for x is g of x, whatever g of x is. Does that make some sense? So if I have an f of x that is equal to x squared, and I have a g of x that's equal to x plus 1, and I want to find f of g of x, that means I'm going to take f and input g of x wherever there is an x in the function f. So in this case, I have x squared. My f of x is x squared, right? So wherever I have the x, I'm going to plug in what g of x is. So this is going to be x plus 1 is what I'm plugging in for x. And then we have to square it because our x in f here is x squared, right? And I just took g of x and I plugged it into the x value in f. And now I'd have to solve this, right? I'd have to multiply this out, which is fine and kind of no big deal, right? But it gives you the idea, right? All we're doing is we're plugging this in. I'm going to just leave it as x plus 1 squared because you guys can multiply out x plus 1 squared if you needed to. But I want to get into more problems with it. So, but this is what f composed with g is, right? This is f composed of g. We plug g into f, right? We plug Stalin into Bugs Bunny, right? Now, if I wanted to go the other way, if I wanted to plug Bugs Bunny into Stalin, which anyone who came in late is going like, what is she talking about? But I'll show them, right? If I wanted to do the same thing, On the other side, so now I've got G, right? And I'm plugging F into G. So I have G of X, and I'm going to plug F of X into it. So I have X plus 1, and where the X is, I'm going to put in X squared. And then I'd wind up with X squared plus 1, right? Because I took my F of X and I plugged it into the X value. So it's not a super complicated thing, but it can be. So, because you have to figure out what the domain of these is. Like we were talking about the domains with the fractions, right? When there's a variable in with the fractions, we have to know what X can't be. The domain of F of G would be all X's in the domain of G that are also in the domain of F, right? So basically anything that's true for both. So in this case, like the domain of F, what I could plug in for X on this F of X, all real numbers, right? I can plug in anything for X in that. And if I look at G of X, there's really nothing that I can't plug in for X there. So in this case, the domain would be all real numbers. Should think calculus. Sometimes some people think that when they hear it like without Stalin and Bugs Bunny. So so she wouldn't be totally wrong. Um, let's do an example or two, and then I'll let you go. I think this is really all I've got for you on this. I'm not going to do the decomposing of functions with you because I just think it's ridiculous. There's really no reason that never mathematically will I ask you to decompose a function, nor no matter how far in math you get, will anyone else ask you to decompose a function. So I don't see any reason for me to start you on that path. Um, let's look at if I have, for example, f of x equals x plus 2, and we'll call it g of x equals 4 minus x squared. Um, if I want to find out what f of g of x is, we're going to plug g into x, right? So anywhere I have an x right here, I'm going to plug in 4 minus x squared. So here I'm going to have 4 minus x squared plus 2, right? And then we're going to simplify it. We're not going to leave it like that. And that would be minus x squared, 4 plus 2 is 6, and it would look like that, right? Perfectly valid. What if I wanted to find g of f of x? Now we're going to take Bugs Bunny and plug it into Stalin, right? So I have 4 minus x squared. So here I'm going to put where my x is, x plus 2, and that would be squared. Do I want to do the math on that? I kind of don't, but I will because why not? I got nothing better to do. So when I look at this, then I would do like x. This is like saying x plus 2 times x plus 2, right? Where we would get x squared plus 4x plus 4. And then over here, we also have 4 minus it, right? And then we just put our stuff together. So I have 4 plus 4 is 8. I have minus x squared plus 4x plus 8. Right, but I just worked that math out. It's not that big of a deal, right? We just squared the x plus 2 and made sure that that 4 was added to it. I feel like my math is bad. Oh, did you see what I did on that? Did you see where I screwed that up? I'm a little disappointed that you didn't. So I have this right here, right? I got to distribute that negative. You see what I mean? Like this is 4 minus whatever this comes to, which means that I have to distribute this negative through to each part of this afterwards. So technically this is 4 minus x squared minus 4x minus 4. See how I screwed that up the first time? Does that make a little sense? I should have just left it alone. So now I have minus x squared minus 4x. And these 4's are going to disappear because I'm left with 4 minus 4, which just zeroes out. And so this winds up being our composition of the function. What if I was asked to find g of f of negative 2? Well, I don't have to go back through all of this because I already know what g of f is, right? I know that g of f is minus x squared minus 4x. So if I want to solve that and I've already figured out what g of f is, I'm just going to plug negative 2 in to these x values and solve it because we already found g of f of x. So I would go minus negative 2 squared minus 4 times negative 2, and we could solve it from there. Negative 2 squared is 4, but we have that negative on the outside of it, so it's negative 4. Negative 4 times negative 2 is plus 8, and we go negative 4 plus 8 is just 4. So we went from all of that mess down to 4, right? I'm trying to see if I need anything else to tell you. That was the whole problem I just worked out with you guys. It took a page and a half to work that out, and we did it like right there in that little area. So I'm going to do one more with you, then I'm going to let you go. Fair enough? Then it can be time for your weekend unless you guys have a class after this one. Do you guys like my new whiteboard app? I spent a lot of money on it, so I hope you do. Right now it isn't super awesome, but I can actually like bring pictures and graphs and stuff into this one, which I think it'll make it better for us in the long run because, you know, I'm not that great of an artist. So I'm going to scroll up on this. I'll bring it back down if you guys need it later. And we're going to do one more problem. We're going to go given, oops, do it in purple because purple's red. Given f of x equals 2x plus 5 and g of x equals 4x squared plus 1. I hate it when it's a square. It means I'm going to have to work harder. We want to find f of g of x, g of f of x, and c f of g of 1/2. So whatever we find for the top one, that's what we're going to plug this negative 1/2 into, right? Because that's the f of g. So let's start with A. We want to find f of g, which means that we are going to plug g in to f of x. So we've got 2x, so where my x is, I'm going to plug in 4x squared plus 1 plus 5, right? And so all we have to really do with this one is some distribution, right? Some distributing and simplifying. So this is going to give me 8x squared plus 2 plus 5. And if I want to redo that nicely, it would be 8x squared plus 7. Not so bad. What do I know? I know that when I come down to do part C, this is what I'm plugging that negative 1/2 into, this equation. So let's go and do part B where we find g of f. That one looks like it's going to be a little harder because I'm going to have to square at some point. So I'm going to go B. I need a little bit more room so I can see those equations. So B says that we're going to take g of f of x, right? Which means that we are going to start with this and we're going to plug that 2x plus 5 into where that x squared is. So we've got 4x squared. So I'm going to have 4 times 2x plus 5 squared plus 1. So what does that look like? I'm just going to leave it like that for now because I'm not plugging anything into it. But I can multiply out those squares if I want to, right? I don't want to. C, if we look at C, it wants me to find f of g of negative 1/2. Well, we know what f of g is, right? It's 8x squared plus 7, right? We already found that. It's right there. And so now we just need to take that, and wherever there's an x, we're going to plug in negative 1/2. And what does that multiply out like? Well, I'm glad you asked. I'm going to show you right now. So negative 1/2 squared is going to become a positive because a negative times a negative is a positive. So we're going to wind up with 8 times, well, 1 squared is just 1 and 2 squared is 4. And so we've squared that 1/2 now plus 7. And when I go 8 times 4, well, that's 8/4, which is 2, right? It's 8 over 4. And so that's just going to be 2 plus 7, which equals 9. So these compositions aren't too difficult, right? You can find this out. You can figure this out. You just have to remember, oh, where did we lose Stalin to? We got, if f of x is Bugs Bunny and g of x is Stalin, we plug Stalin into Bugs Bunny here, and here we plug Bugs Bunny into Stalin, right? Works every time. It's just you have to know what you're plugging in. What are you plugging it in for? The x variable, right? Because that's what our input is. I don't know if I have anything that would be better as far as explaining it. I think that's pretty good. You do need to be able to define the domain, though, in terms of what works. And it's basically whatever works for both is your domain. It can't just be a domain for one and not be a domain for the other, right? Like if I had, I'm trying to look at these where I'm trying to find something where the domain isn't just like all real numbers. So let me scroll down here and see what our original problem, like here I've got 2x plus 5. X can be anything in that, right? There's no limits on x. In g of x, there's no limit on x. But if I had a function that was say I had one that was like f of x equals x plus 1. And then I had a g of x that equals 1 over x plus 2. Like we know that x can't be negative 2 in g of x, right? There's boundaries on the domain of g because we can't have a 0 in the denominator, which means that if I have f of g or I have g of f, 0 can't be a part of either of their domain, right? I mean, negative 2. Negative 2 can't be a part of either domain because that's what's going to make this 0, right? Does that make some sense? So when I plug this in, my domain of these functions would be all real numbers except for negative 2. So I go, okay, well, I can go, stop it. I can go from negative infinity to negative 2, right? But I can't include negative 2, so it's going to be a parentheses. And then I would start again at negative 2 and go all the way to 2 and not include 2. And start again at 2. I don't know why I'm doing that. I only need the negative 2 one. I'm like adding more work than I thought. I was going back to the one I did earlier. I'm losing my mind. This can actually go all the way to infinity. The only I can include 2, I just can't include negative 2, right? And so that is all real numbers except for negative 2, right? And I know it seems like a long-winded way of saying it, but I'm pretty sure that WebAssign isn't going to allow you to put it in as writing all real numbers except for negative 2. You're going to have to know your interval notation to be able to plug that in. So just remember, parentheses mean we're not including it. Brackets mean we are. So when we're looking for these domains and we're trying to exclude something, more often than not, you're going to be dealing with parentheses when it comes to negative numbers. I mean, composition of functions, because we're excluding something, right? So I hope that makes some sense. I hope you enjoyed Stalin and Bugs Bunny as much as I did. If you have any questions about it, please let me know. Don't forget that tomorrow is the last day of our triad. After tomorrow, assignments will be closed out and you will have no access to them again. If you need a wee bit more time on something, I probably won't get to grading until like Sunday. So this week isn't due till next week, Jamila. So nothing that was assigned this week will count in your triad grade. So it's just the stuff before 1.8, everything before 1.8. I actually have to go in and put this assignment into WebAssign, which I'll do as soon as I shake y'all loose. I'll do that. But that's all I've got for you. I'm going to stop recording. So